So today we're solving exponential equations, which we've done some where we change the bases to the same base so that you can set the exponents equal each other. Well, logs come in handy when you can't get the same base on each side. So I can't, like the first two are old questions you know how to solve. You just get the same base. So 5 to some power, and I can write 25 as 5 squared. And then since the bases are the same, you can set the exponents equal to each other. So n plus 10 can equal 2. So n would equal -8. So no problem there. Solve this one. Base 981 can't go, but 3 can. 3 squared is 9. Power to a power, you multiply. 3 to the third, power to a power, you multiply. Right? So the exponents equal. And then I'm not going to waste your time. You know how to solve that equation. Solve it just like normal. And you'll get the answer A equals 1. Okay? So then we move on. What if we cannot get common bases? So like this base I can get 5, this base I can get 5. But here I can't get a base of 2 to equal 61. It's 2, 4, 8, 16. Let me think of my 2s real quick. 2, 3, 4. It's not possible, but we'll prove it. 5, 6. So that's 4, 8, 16, 32, 64. See, it jumped over that one. So isolate your exponential expression. So the number being raised to the x. So b being raised to the x. That's an exponential expression. Take the log of both sides. So what's nice is if you take the log of both sides, that's the hard way to do it, when you could just write this in logarithm form and then solve. So I'm going to skip that step and write it in a logarithmic form. There we go. Because 2 would be my base. Log base 2 of 61 would equal x. And so then you just put that in the calculator. These are old kind of notes. Why they don't want you to do this is because most of the time in the old times you can't put base 2 in the calculator, but now we can. So we can just do that's geometry, I'm in. Log base 2 of 16. No, log base 2 of 61. My dysgraphia is kicking in. .9307. I'll just do 100. Rounded answers may not produce the exact same, but will be very close. So we'll just 5.9307. Write it all out. So, and then to check it, you can plug it in. 2 to the 5.9307. It's not 61 because we rounded it. The calculator rounded it. It would be better if I used this exact number right here. Because see how it's not rounded, and that should give me 61. But nobody wants to write all of that. So if this rounds to the right number, I'll take the answer. That is the answer, 5.9307. The old way they do it, I'm just going to show you. This is how Delta Math solves it, which is why I'm going to show it to you, and I'll rewrite what I have written. Is they take the log of both sides and then use your power rule to bring down your x. And divide by log 2. So then x would equal log 61 over log 2. And that's how you put it in the old calculators. But that's the same thing as log base 2 of 61, how I just solved it. And this is way more complicated. So that's why I'm not. Like, it works. If this is how you want to solve it, you're more than welcome to. You can pause the video and copy that down. But I'm going to teach it the easiest way. Who doesn't like to learn the easiest way? So I'm going to pause the video and rewrite it how I had it, but that's just how you could solve it. Okay, so even though I'm teaching a different way, you still have to do the same steps. You still have to isolate the exponential. So 4 to the n. We have to get the 7 to the n. We have to get rid of the 4. So the 4 is there with multiplication, so we'll divide. So we have 7n equals, divide that, I get 37. And then we're going to change it into logarithmic. So log base 7 of 37 equals n. And then you can just put that in the calculator. If you look at your multiples of 7 to the first obviously is 7 squared is 49. You know it's going to be closer to 2, just so you know what your answer should be around. So your answer should be closer to 2 than 1. So 1.8 maybe. Log 7 of 37. 1.85564. I'm going to use that whole decimal because the more I round, the less accurate my answer is. So see how it's closer to 2 than 1. All right, keep going. We're isolating. I'm just going to do the odds. We're isolating the exponential, so I have to get rid of the positive 7. So I'm going to subtract 7. You want to get down? Okay, you can get down. The negative is not part of the exponential. The 4. So we can get rid of, this is being multiplied by -1. Otherwise, it'd be in parentheses. So we can get rid of the negative by dividing over by -1. So then we'll get 4 to the x plus 1. It was -11. Write an exponential. Log base 4 of -11 equals x plus 1. And then I'd actually have to solve a little bit more by subtracting over 1. But you can stop right here because you can't take the log of a negative number. So no solution. Can't take the log of a negative number. Should I leave that up there? You can always pause the video if you need to slow down and copy it. So isolate your exponential. So 3n is what I'm trying to get alone. And you're doing the order of operations backwards. So you're doing, when you solve, you're adding or subtracting first before you multiply or divide. So here I'm subtracting 15. 4 times 3n equals 344. Trying to get 3n alone. Divide by 4. 3n equals 86. Put in the calculator. Now I can write it as exponential because there's no way to do 3 to any power to get 86. Just to know where our answer is going to be. You don't have to do this. I just like having an idea. What in the world am I solving? Where would it be? So that's 9, 27, 81. 243. So if we're trying to get 86, n is going to be 4.5 or something like that. So close to 81. But we got to write it in logarithm. Log, base of your exponent becomes the base of your log. Bless you. Raised to the 86 equals n. So log base 3 of 86 equals 4.0545. 4.0545. I think it was a 2. Let's write it all out. On the test, I'll tell you what to round to. Right now, I'm just writing anything the calculator says. Because remember, this is still rounded. So it's not giving me 86, but it's giving me really close to 86. The better number to use is the non-rounded number, but nobody wants to write all of that down. Look at that. That'd be crazy to write down. So as long as it rounds to the correct answer, I'm good with it. 2 more, and then I will get on the video and work some evens with you. So we're isolating this. These get a little harder. I'm going to subtract over 1. 5 times n to the v minus 1 equals 180. Trying to isolate my exponential. Divide by 5. 180 divided by 5 is 36. Write it in logarithmic. So log base of my exponent becomes the base of my log. 36 equals v minus 1. Then I still have one less step to add over the 1. So log is 9. We're taking the log of 36 and adding 1 to that. So make sure you don't put 37 or you don't put a 1. Make sure it's not taking the log of 37. 26309. 2.6309. I think it gave you another number. 2, 3. I just love that you can check your answer. That's my favorite part about math. You can always check your answer. So I'm going to add over 2. 6 times 16, 7y plus 2 equals 84. Divide over by 6. Trying to isolate 16. So 16, 7y plus 2 equals 14. Once you get your exponential alone, you can write it in logarithmic form. So log base 16 of 14 equals the whole exponent, 7y plus 2. And we're going to leave this. It's just a number, but we're going to leave it all like that so we're not rounding. And then we'll subtract 2 and divide by 7. So log base 16 of 14 minus 2, all of it divided by 7. I type it in. Log base 16 of 14 minus 2, all divided by 7. Negative 14.9737, negative 14.9737. I put that decimal in the wrong place. So there's your answer. All right, I will be on during your class to help you with the evens. Hopefully today's an easy lesson. On the Delta Math for today, I did put different types of logarithmic equations. And if you watch their video, it is not the same as how I taught it. I'm sorry, but they're teaching it the hard, longer, old way when this is the easier, quicker way. Okay?